In this example, we'll try to find the antiderivative of this given cosine function. Okay, so we have here something on the numerator of this cosine function given as 1 plus t square, and on the denominator, or let's say at the bottom, we have square root of t, and then we want to find the antiderivative of this. But the thing is, we do not have any quotient rule that is available over here on the antiderivative, which we could just directly use, right? So because of that, I'm trying to see if I can just write down in an alternative form. Sometime it helps. So right now here I see a couple of things I can do. One is maybe just divide. There are three terms at the top, and then I can divide each term of the top by the bottom, right? And then even at the bottom, you can, if you look into it, there is a square root of t, so that can be also changed into what, a t to the power 1/2, right? So on the exponent form. So let's do that and then see what could be the alternative, okay, form. So if you look into the function here, given is 1 plus t square divided by square root of t, means something like what, t to the power 1/2, right? So that's what we can see. And then even now, if I write down in that way, each term at the top can be divided by that bottom, so we can write down this as 1 over t to the power 1/2 plus t divided by t to the power 1/2, right? So plus t square divided by t to the power 1/2. So now if I divide in that way, the first term can be written as, so this is 1 over t to the power 1/2. So if I want to write down this into the negative exponent form, this can be written as t to the power negative 1/2, right? So plus the second term, if you look into it, we have t over t to the power 1/2. So there are a couple of exponent laws, which is something like, let's say if you have x to the power let's say if you have x to the power x to the power m divided by x to the power n. If you have the same base, we can combine the power by subtracting it. So we could use that kind of law, that exponent law here, to combine this over here to rewrite the second term. So we have something like over here on the second term 1, you can assume in that way. So if we assume in that way, then we have t to the power 1 minus 1/2, right? So on the power, if you subtract the power, so we'll have 1 minus 1/2. But what is 1 minus 1/2? Just 1/2. So we could just write that down then. Okay, so in the same way, the last one also, like in the second term, we can manipulate this as t to the power 2 minus 1/2. So what is 2 minus 1/2? So 2 times 2 is 4, 4 minus 1 is 3, so 3 over 2, right? So 3/2 then, so why don't we write that down? So then we have 3/2. So that's how we can rewrite this given problem. So our function was this cosine function, but now based on this work, you saw that this can be just written as that form. I have not done any antiderivative, I have just rewrite the problem, okay? So if that is the case, let's try to work with that this alternative kind of form, okay? So rather than now integrating the current format, I want to integrate with the t to the power negative 1/2 plus t to the power 1/2 plus t to the power 3/2. Don't assume that all the time. If we have the cosine function, we can split in this way and then find the entire derivative, but on this particular case we are able to, so why don't we use that one, right? So now if I split in that way, you saw that each term I can integrate, right? So t to the power negative 1/2, I can use the power rule. Over here also I can use the power rule. I can also use the power rule there, and then just find the entire derivative. So let's apply that. So what should be the entire derivative of t to the power negative 1/2? That will be t to the power negative 1/2 plus 1, right? So negative 1/2 plus 1. But what is negative 1/2 plus 1? Means that means just 1/2. So then just write it down on the power, but because the power rule says, okay, also multiply by the reciprocal of that, so we need to do that. Then 2 over 1 times t to the power 1/2 is the entire derivative of t to the power negative 1/2. So that is the first term. Let's play with the second term. So we have t to the power 1/2, then its entire derivative would be t to the power 1/2 plus 1 in the power, but 1/2 plus 1 mean what? 3/2. So then we can write that down, and then don't forget to multiply also by the reciprocal of that. So we have then 2/3 t to the power 3/2 is the entire derivative of the second term, and do the same thing to the last one. So we have t to the power 3/2. So then we'll have 3 to the power 3/2 plus 1. 3/2 plus 1 mean what? 5 half, right? So then we can write that down over here, and then don't forget to multiply also by the reciprocal of that plus the general integration constant. Done. This should be the antiderivative of the given function here, right? So this is it. We can definitely convert this into the exponent, what was that, the radical form, and then it's like simplify or write down into other alternative form. But this is definitely one of the antiderivative of this given function over here.